Welcome to Atomic Analyzer, where we break down the most fascinating concepts in science. Today, we're diving into one of the most revolutionary theories ever created, Albert Einstein's theory of general relativity. It's the theory that reshaped our understanding of space, time, and gravity. But don't worry, whether you're a science enthusiast or just curious about how gravity works, we'll break it all down for you in a way that's simple, clear, and engaging. At its core, general relativity is a theory about gravity. But unlike the way Isaac Newton described gravity, where objects are pulled together by an invisible force, Einstein had a completely different idea. Imagine space and time as a kind of flexible fabric. Massive objects like planets and stars bend and warp this fabric. This curvature tells objects how to move. In other words, gravity isn't just a force pulling things down, it's the effect of objects moving through the curved space around them. Think of it like a trampoline. If you place a heavy ball in the center, the trampoline bends. Now, if you roll a smaller ball on the trampoline, it will naturally move toward the center. That's similar to how planets and stars interact in space. Before Einstein, gravity was a mystery. Sure, we knew that objects fell toward the Earth and that planets orbited the Sun, but no one knew why. In 1915, Einstein's theory of general relativity answered these questions in a completely new way. Einstein realized that space and time weren't two separate things, they were one thing, a four-dimensional fabric called space-time. And when objects with mass exist in space-time, they cause it to curve. This curvature of space-time tells objects how to move, which is what we perceive as gravity. In 1919, during a solar eclipse, scientists proved Einstein's theory. They observed that starlight passing near the sun was bent, just as general relativity predicted. So, what does all this mean for us? Why does general relativity matter in our daily lives? Well, for one thing, it's the reason why we have GPS. Satellites orbit the Earth in space, where time flows a little differently because of general relativity. If we didn't account for this difference, our GPS systems would be off by several kilometers. So every time you use your phone to find a location, you're benefiting from Einstein's genius. General relativity also helps scientists understand how the universe works. It explains things like the motion of planets, the behavior of light near black holes, and the expansion of the universe itself. One of the most exciting things about general relativity is that it made several predictions that were later confirmed by observations. Black holes. Einstein's theory predicts the existence of black holes, regions of space where gravity is so strong that nothing, not even light, can escape. Decades later, scientists found evidence of black holes, making this one of the most exciting confirmations of the theory. Gravitational waves. Another mind-blowing prediction is the existence of gravitational waves, ripples in space-time caused by massive objects like colliding black holes or neutron stars. In 2015, scientists detected these waves for the first time, confirming another part of Einstein's theory. Time dilation. General relativity also predicts that time flows more slowly near massive objects. This effect, known as time dilation, has been confirmed by experiments. Astronauts on the International Space Station actually age more slowly than people on Earth, though the difference is tiny. General relativity didn't just change the way we understand gravity, it also gave us a new perspective on the universe as a whole. In the 1920s, scientists realized that the universe wasn't static, it was expanding. This discovery, which was based on Einstein's equations, led to the development of the Big Bang theory, the idea that the universe began from a singular point and has been expanding ever since. Today, the theory of general relativity continues to help us explore some of the biggest questions in cosmology. What is dark energy? How did the universe begin? What will happen to it in the distant future? While general relativity has been incredibly successful, it's not the complete picture. One of the biggest challenges in modern physics is figuring out how to combine general relativity with quantum mechanics, the theory that governs the tiny world of particles. Right now, these two theories don't quite fit together, and finding a way to unite them is one of the major goals of physicists today. This is where theories like string theory and quantum gravity come into play, as scientists continue to search for a theory of everything. So, there you have it, general relativity, one of the most important scientific breakthroughs of all time. It's a theory that changed the way we see the universe and has opened the door to incredible discoveries, from black holes to gravitational waves. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss out on our next video. And be sure to leave a comment. What do you think about general relativity? Could there be even more to discover about gravity?